Okay, we're going to keep going with the hallway activity. We're going to move on to the next one. Next one's a little bit of again, a little trickier one. I like showing some of the trickier ones just to kind of, if you understand these, it really does help. Okay, so a flag is being raised on an 84-foot tall flagpole at a rate of 1 foot per second. So what that tells me is that this whole height here is 84 feet, 84 feet. And it's saying it's being raised at a rate of 1 foot per second. So again, if you think about this, we're talking about like the height, or in this case, we're going to talk about dy dt. It's going to be 1 foot per second. Okay. A revolving camera mounted on the ground 35 feet from the base of the flagpole is recording it as the flag is raised. So again, we're going to have our camera here. So you're going to see my great art skills. There's my camera. It's mounted, and I know for a fact this right here is going to be my fixed, my known, my constant. This guy right here is 35 feet away. I know for a fact that's never changing. The camera's going to kind of angle up as we go and we look at this. So now what's happening is the camera rotates upward as the flag is raised, forming the angle theta. How fast is the angle theta changing when the flag is 35 feet above the ground? So what it's saying is when this height right here is 35 feet, what is going to be d theta dt? That's what it's asking us. So if you think about this, we're dealing with the angle. And if you think about the pieces of the triangle we have this side and we have this side here. We have this side here and this side here. From the perspective of this is my adjacent. This is my opposite. So what that tells me is, since I'm dealing with an opposite and an adjacent, I'm dealing with a tangent function. So what that tells me is for number 7, I'm going to be dealing with tangent theta is going to equal opposite over adjacent. So opposite is going to be this y value. Adjacent is going to be this x value. So I'm going to write it down as opposite y over adjacent x. So that's opposite and that's adjacent. And what I need to look at is I need to look at which one of those numbers is fixed. Is my up and down fixed, or is my left to right fixed? And in this case, my left to right is fixed. It's 35 feet. It's always 35 feet. So what that tells me is that this tangent theta is going to be equal to y over 35, or tangent theta is going to equal 1/35 y. Okay, so now I can do my implicit differentiation. I'm going to take the derivative. The derivative of tangent of theta is secant squared of theta. Sorry, d theta dt equals 1/35 dy dt. So I know from my problem that this guy is 1. This is what that said right there, 1. So I know that secant squared theta times d theta dt is going to equal 1/35. So I need to figure out what secant squared theta is. Okay, so here is the trick on this one. In order to figure out secant, I ask this question all the time. What is secant? Everybody likes to say secant is 1 over cosine, and that's right. That's good, but that still doesn't help. It's in terms of another trig function. So let's figure out what cosine is. So cosine is adjacent over hypotenuse. It's adjacent over hypotenuse. Okay, now here comes the trick on this one. This right here is the triangle I'm looking at. I'm dealing with this triangle right here, 35, 35, and then there's my hypotenuse. So I need to figure out what that hypotenuse is. What is that hypotenuse? So if I can do it 2 ways. So let me show you the 2 ways to do it. The first way is I could just use Pythagorean theorem. I could say a squared plus b squared equals c squared. So a squared 35 plus b squared 35. So I could just say that hypotenuse is equal to 35 squared. All right, sorry, hypotenuse squared is 35 squared plus 35 squared. So that tells me that hypotenuse squared is equal to 2 times 35 squared. Take the square root of both sides. I could say that the hypotenuse is equal to the square root of 2 times 35 squared. That's one way. So now that I have hypotenuse, which is wonderful, I can go ahead and I can substitute in here, and I can say, well, cosine of theta is equal to adjacent, and the length of the adjacent is 35, over the hypotenuse, which is 2 times 35 squared, that whole thing. But remembering I need to turn it into secant, so secant is the inverse of it. So what that tells me that secant theta is equal to the square root of, the square root of 2 times 35 squared over 35. But I don't need secant, I need secant squared. So what I'm going to do is square both sides. And that's going to give me secant squared theta. What that's going to do is get rid of that square root up top, make it 2 over 35 squared. The denominator is going to be 35 squared. That tells me cancel out. That tells me that secant squared of theta equals 2. The other thing I could have done if I wanted to, and this is a little bit of a quicker way, is if you notice, I have a right triangle where the two sides are the same. And if you remember in your unit circle where your x and your y length are the same is where theta equals pi over 4. So when theta equals pi over 4, you have equal length sides. It's when you have two equal length legs. So what I could have done is I could have made theta equal pi over 4. I could say secant pi over 4. And when I do secant of pi over 4, that's going to be 1 over cosine pi over 4. From our unit circle, cosine of pi over 4 is root 2 over 2. So that tells me that the secant of pi over 4 is a reciprocal. It's 2 over root 2. Again, I need to square both sides. And that's going to tell me that secant squared of pi over 4 is going to equal 2 squared, which is 4, over the square root of 2 squared, which is 2, which is also 2. Either way is fine. So I know that this guy is 2. So this is 2 d theta dt equals 1/35. I'm going to multiply both sides by 1/2. Multiply both sides by 1/2. And that's going to tell me d theta dt equals 1/70th. Since we're talking about angle measurements, it's radian per second. 1/70th of a radian per second. It's what it's doing in this case is how fast is it when we're raising it, it's going up at 1/70th radian per second. So that's the answer to number 7. Okay. Number 8, and you might get a bell ring in the middle of this, so just be prepared. A pebble is dropped into a compound causing concentric circles to be formed. The radius of the outside ripple is increasing at a constant rate of 0.5 feet per second. When the circumference of the outside circle is 20 feet, what is the rate that the total area of the outside circle is changing? So we're talking about area of a circle, so area equals pi r squared. We're asking to find the rate of change of the area, so we're actually asking to find this. So we need to know dr dt. According to this problem, the radius is increasing at 0.5 foot per second, so that tells me increasing positive 0.5 foot per second. And I know that in this case, the circumference of my circle is 20 feet. So kind of like that one before, circumference equals 2 pi r. The circumference of the circle is 20 feet. So that tells me 20 equals 2 pi r. So that tells me that radius is going to equal 10 over pi. So now I'm going to do, I'll do it here because it's a shorter one. dA dt equals 2 pi r dr dt. I'm trying to find dA dt, so I'm going to plug in everything. 2 pi, the radius is 10 over pi. 10 over pi. dr dt is 1/2. Cancel, 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 cancel. So it's going to tell me that dA dt is going to be increasing at 10 square feet per second. So that guy's 10 square feet per second. So that's the answer to number 8. I'm going to hit pause right now because the bell's about to ring the end of the day, and I'll start the next one in a second. Okay, this next one's going to go a little bit quicker because it's a more straightforward one, I guess. Okay, so this is talking about a cube. So all edges of a cube are shrinking at a rate of 0.6 centimeters per minute. So that's telling me that the derivative of the side with respect to time is negative 0.6 centimeters per minute. How fast is the volume changing when each edge is 10 centimeters? So that tells me that one side is 10 centimeters. And it's actually asking me to find dV dt. So volume equals side cubed of a cube. So dV dt, implicit differentiation, equals 3s squared ds dt. So dv dt is going to equal 3 times 10 squared times negative 0.6. So that's going to give me 300 times negative 0.6. That's going to give me negative 140. And what we're going to talk about is cubic centimeters per minute, because it's sides are getting smaller, cubes getting smaller. So that's why that is doing it. So that gave us 7, 8, and 10. What we're going to do is I will do the next ones on the next video.